It begins with a question so simple that almost everyone has thought about it at least once, usually late at night or in a quiet moment when the world feels still. And that question is this: why does anything exist at all instead of nothing? Because when you really pause and think about it, the idea of nothing is strange in a way that's hard to even picture, like trying to imagine a completely empty room with no walls, no space, no darkness, not even silence. And you might ask yourself, what would that even feel like? What would it look like? And the honest answer is that we can't truly imagine it, because every thought we have always includes something, even if it's just a blank space. And that's where the mystery begins. Because if nothing is so hard to even think about, then why isn't that the default? Why isn't there simply nothing at all? No universe, no stars, no time, no you listening right now. And yet here we are, surrounded by a universe that stretches so far that if you tried to travel across it at the speed of light, which is the fastest speed anything can move, it would still take longer than the entire age of human history just to cross a tiny fraction of it. Like trying to walk across an endless desert that never seems to end, no matter how far you go. And this leads to a quiet but powerful realization that existence itself is not something we can take for granted, because it didn't have to be this way, or at least it feels that way. And that raises another gentle question: does existence need a reason, or is it simply there, like a fact that doesn't need explaining, the way a mountain just stands without asking permission? But then again, even mountains have causes. They form over time through pressure and movement deep within the earth. So if everything we see has some kind of cause or origin, then what about everything as a whole? What about the universe itself? Does it have a cause too, or is it somehow different? And many people assume that science already answered this, that the Big Bang explains everything. But that's actually a common misunderstanding, because the Big Bang describes how the universe expanded and changed after it began, not why it began in the first place. It's a bit like watching a video of a balloon inflating and thinking you understand where the balloon came from, when really you're only seeing what happened after it started expanding. So the deeper question remains untouched. What set everything into motion? What made existence begin instead of remaining as nothing? And when you sit with that question, it can feel both calming and unsettling. At the same time, calming because it reminds you how mysterious and vast everything is, and unsettling because there may not be a clear answer waiting at the end. And yet, humans have always been drawn to this question. From ancient thinkers staring up at the night sky to modern scientists studying distant galaxies through powerful telescopes, all of them asking, in different ways, why is there something rather than nothing? And you might wonder, is this even a question we can answer? Or is it one of those things that will always stay just beyond our reach, like trying to see the edge of the horizon, no matter how far you travel? And still, even if we never find a final answer, the question itself changes the way we see everything. Because once you realize that existence didn't have to be, every small detail starts to feel more meaningful. The air you breathe, the ground beneath your feet, the quiet hum of life all around you. It's like noticing that every grain of sand on a beach exists against incredible odds, and yet there are billions of them. And in the same way, the universe is filled with countless stars and galaxies, each one a reminder that something exists where nothing might have been. And so the question gently stays with us, not demanding an answer, but inviting us to keep wondering, to keep exploring, and to remain curious about the simple fact that anything exists at all, including us, here in this moment, able to ask the question in the first place. As we move forward, feel free to share where you're listening from, or leave a quick thought below. And if this channel means something to you, subscribing is a small way to support the journey. If we follow that quiet question a little further, we eventually arrive at a moment that feels almost impossible to imagine. A moment when everything we know, every star, every galaxy, every bit of space itself, was once compressed into something unbelievably small. So small that it's often described as a single point. And you might wonder, how small is that really? And the closest way to picture it is to imagine taking everything you see around you, every building, every mountain, every ocean, and somehow fitting it into something smaller than a grain of sand, and then shrinking it even more, until the idea of size itself almost stops making sense. And from that state, the universe began to expand, not like an explosion in space, as many people think, but more like space itself stretching outward in every direction at once, like dots drawn on the surface of a balloon, moving away from each other as the balloon inflates. Except in this case, there is no outside of the balloon, because the balloon is everything, and this event is what we call the Big Bang, though the name can be a little misleading because it wasn't a loud bang in the way we usually imagine. There was no sound echoing through empty space, since space itself was just beginning to exist. So what actually happened in that first moment? What did it look like? The honest answer is that we don't fully know, but we do know that it was incredibly hot and dense, so hot that if you could somehow feel it, it would be like being inside a fire, hotter than millions of suns combined, like standing next to countless glowing furnaces, all packed into a space smaller than a single atom. And as the universe expanded, it began to cool, slowly at first, then more and more over time, and this cooling allowed the first simple particles to form, tiny building blocks that would eventually come together to create atoms, and those atoms would later form stars, and those stars would create heavier elements like carbon and oxygen, the same elements that make up your body right now. And that leads to a quiet realization that often surprises people, that in a very real sense, the atoms in your body were forged in the hearts of ancient stars that existed billions of years before Earth was even formed. It's like being made from the dust of long-gone fires scattered across the universe. And you might pause and wonder, how do we even know any of this? How can we talk about something that happened so long ago? And the answer comes from the light that still travels through space today. Because when we look at distant galaxies, we are actually seeing them as they were millions or even billions of years ago, since light takes time to travel. So looking deeper into space is like looking back in time, almost like watching an old recording of the universe's past. And scientists have even detected a faint glow spread across the entire sky, known as the cosmic microwave background, which is like a leftover heat signature from the early universe, a kind of afterglow that fills space in every direction. And if you could see it with your eyes, it would be like a soft, dim light surrounding you everywhere, almost like being inside a room where the walls gently glow. And this glow gives us clues about how the universe began and how it has changed over time. But even with all this knowledge, a gentle question remains. What was there before this beginning? Or does that question even make sense? Because time itself may have started with the universe, which means there may not have been a before in the way we usually think. And that idea can feel a bit strange, like trying to imagine what is north of the North Pole, where the concept of direction simply stops applying. And yet, even if time began at that moment, we are still left with the mystery of why it began at all, why there was a beginning instead of nothing continuing forever. And as you sit with that thought, the universe starts to feel less like a simple place and more like a story that is still unfolding, a story that began in a moment we can barely comprehend and has continued for billions of years, slowly shaping everything we see today. And even now, the universe is still expanding. Galaxies are still drifting apart, like dots on that ever-growing balloon. moving farther and farther away over time. And you might wonder, will it ever stop? Will the universe keep expanding forever? Or will something change in the distant future? And while we don't yet have a final answer, the fact that we can even ask these questions, that we can trace our origins back to a moment when everything began, is something quietly remarkable, because it means that from that tiny, dense beginning, a universe emerged that could eventually become aware of itself through us, through our thoughts, through our curiosity. And in that sense, the beginning of the universe is not just a distant event. It is something that is still connected to us right now, like the opening moment of a long story that we are still living inside, still trying to understand, and still gently exploring with each new question that comes to mind. As we gently stay with the idea of a beginning, another question naturally rises, almost as if it has been waiting quietly in the background this whole time. And that question is simple but deep. What caused the Big Bang to happen in the first place? Because even though science has done an incredible job describing what happened after the universe began, how it expanded, cooled, and formed everything we see today, it becomes much quieter when we ask what actually triggered that beginning. And you might wonder, is there even an answer to that? Or is this where our understanding starts to fade, like a path that slowly disappears into fog the further you walk? And one common thought people have is that the Big Bang was an explosion of something that already existed, maybe a tiny particle or a dense object. But that's actually a bit misleading, because according to our best understanding, it wasn't an explosion inside space. It was the expansion of space itself, which means there may not have been a place where it happened. And that can feel confusing at first, like asking where a dream is located when you're inside it. And this leads to another gentle question. If there was no space before the universe and no time before the universe, then what could have possibly caused anything to begin at all? Because in our everyday experience, every event has a cause. A seed leads to a tree, a spark leads to a fire, a push leads to movement. And we are so used to this pattern that it feels natural to expect the universe itself to have a cause as well. But here is where things become a little different, because cause and effect depend on time. One thing happens before another, and if time itself began with the universe, then there may not have been a before for a cause to exist in. And that idea can feel strange, almost like trying to imagine a story that begins without a first page. And yet, some scientists have explored possibilities that try to make sense of this. One idea is that the universe could have come from a quantum fluctuation, which is a tiny, random change that can happen, even in what we call empty space. But here's something many people misunderstand. Empty space in physics is not truly empty. It's more like a quiet field where small, temporary changes can appear and disappear, like tiny ripples on a still pond. And these fluctuations are usually extremely small and short-lived. So you might ask, how could something so small create an entire universe, something as vast as billions of galaxies, spread across unimaginable distances? It's like asking how a single spark could somehow turn into an entire forest overnight. And while some theories suggest that under certain conditions, these fluctuations could grow and expand rapidly, turning into something much larger, this still doesn't fully answer the deeper question. Because even if a fluctuation started it, where did the laws that allow those fluctuations come from? And why do they exist at all? And this brings us back to that quiet edge of understanding, where every answer seems to open another question, like stepping through one door only to find another waiting behind it. And there are also ideas that suggest the universe might be part of a cycle, where it expands and contracts over and over again, like a slow, endless breathing, with each expansion followed by a collapse, and then another beginning. But even in that case, we can still ask, What started the cycle in the first place? And why does it exist at all? And some thinkers have even suggested that the universe may not need a cause in the way we usually think, that it could simply exist as a kind of starting point, something that doesn't require an explanation outside itself. But that idea can feel a bit unsatisfying, because it goes against our everyday experience, where everything seems to have a reason or an origin. And yet, maybe the universe is not something we can compare to everyday objects. Maybe it's more like the background of everything, something that doesn't fit into the usual rules we are familiar with. And as you sit with this, you might notice that the question itself begins to change. It's no longer just about what caused the Big Bang, but about whether the idea of a cause even applies at that level. And that can feel both humbling and calming, because it reminds us that there are still mysteries we have not yet solved, and perhaps some we may never fully solve. But instead of seeing that as a limitation, it can also be seen as an invitation, an open space for curiosity, for wonder, for quiet reflection, because even without a final answer, the question itself has a kind of beauty, like looking up at the night sky and knowing that beyond the stars we can see, there are still countless others hidden in the distance. And in the same way, beyond what we currently understand about the beginning of the universe, there may be deeper layers of reality waiting to be discovered, and until then, the question gently remains, not as a problem to be solved quickly, but as something to sit with, something to explore slowly, something that reminds us how vast and mysterious existence truly is, and how remarkable it is that we are here at all, able to wonder about the very beginning of everything in the first place. As the question of a beginning settles quietly in the mind, another question begins to take shape, one that feels even more subtle and somehow more difficult to hold on to. And that question is this: can something truly come from nothing? Because at first it might sound simple, almost like a basic yes or no, but the more you sit with it, the more it begins to stretch and blur, like trying to focus on something that keeps slipping just out of view. And you might start by asking, what do we actually mean by nothing? Because in everyday life, when we say nothing, we usually mean an empty room, or a quiet space, or maybe a place where there are no people or objects. But even then, there is still space. There is still time. There is still something present. And in physics, what we often call empty space is not truly empty either. It's more like a calm ocean, where tiny ripples can appear and disappear, where particles can briefly come into existence and then fade away again, almost like bubbles forming and popping on the surface of water. And this leads to a common misunderstanding, because when people hear that particles can appear from nothing, they often imagine complete emptiness suddenly producing something. But that's not exactly what is meant, because this nothing still has structure. It still follows rules. It still exists within a framework, so it is not absolute nothingness. And that raises the deeper version of the question: can something come from true nothing? A state with no space, no time, no laws, no potential, no background at all. And when you try to imagine that, it becomes almost impossible, like trying to picture a color that doesn't exist, or a sound that has never been heard. And so the question begins to shift again. Is true nothing even possible? Or is it just an idea we use because we cannot fully understand the alternative? And some thinkers suggest that nothingness might be unstable, that it cannot remain as nothing, that it naturally gives rise to something. But then you might wonder, how could that be? How could nothing have any kind of property or tendency at all? Because the moment it has a tendency at all, because the moment it has a tendency, it is no longer truly nothing. And so we find ourselves in a loop, where every attempt to define nothing seems to turn it into something, like trying to hold water in your hands only to watch it slip through your fingers. And this is where different ideas begin to appear. Some suggest that the universe may have always existed in some form, even if that form is very different from what we see now. Others suggest that existence might be a fundamental aspect of reality, something that doesn't need to be created or explained in the usual way. And you might ask, does that mean the universe just exists without reason? And if so, is that really any easier to understand than something coming from nothing? Because both ideas seem to stretch our thinking in ways that feel unfamiliar, and yet there is something quietly fascinating about this, because it shows us that the question itself may not have a simple answer, and that's okay, because not all questions are meant to be solved quickly. Some are meant to be explored slowly, like walking through a dark room and letting your eyes adjust over time. And as you sit with this idea, you might notice that the concept of nothing becomes less clear, less solid, almost like it dissolves the more you try to define it. And in its place, there is just this sense of mystery, this open space of not knowing. And instead of feeling uncomfortable, it can feel strangely peaceful, because it reminds you that there are still things beyond our understanding, things that invite curiosity rather than demand certainty. And you might gently ask yourself, if something cannot come from nothing, then does that mean something has always existed in some form? And if something can come from nothing, then what kind of nothing are we really talking about? And these questions don't need immediate answers. They can simply rest in the background, like soft echoes that return every now and then. And in that quiet space, the universe feels a little more mysterious, a little more open, like a story that hasn't fully revealed itself yet. And perhaps that is part of what makes it so fascinating, because it allows us to keep wondering, to keep exploring, and to stay curious about the simple yet profound idea that something exists at all, even if we don't fully understand how or why. And in that sense, the question of something coming from nothing becomes less about finding a final answer, and more about appreciating the depth of the mystery itself, like looking into a vast sky and realizing that no matter how much you learn, there will always be more beyond it, quietly waiting to be explored. As we continue to sit with these quiet questions, another detail begins to stand out, something so familiar that it often goes unnoticed, and that is the simple fact that the universe follows rules, steady, consistent rules that seem to apply everywhere we look, from the way an apple falls from a tree to the way distant galaxies move across space. And you might pause and wonder, why is that the case? Why does the universe behave in an orderly way at all? Because if you think about it, it could have been completely chaotic, with things happening randomly, like trying to play a game where the rules change every second, where gravity works one moment and disappears the next, where light travels fast one day and slows down the next. And yet, that's not what we see. Instead, we find patterns, stable relationships, predictable behavior, like a quiet rhythm that runs through everything. And these patterns are what we call the laws of physics. And they describe how things move, how forces interact, how energy flows. And you might ask, how precise are these laws really? And the answer is incredibly precise. So precise that scientists can predict the movement of planets years in advance, almost like knowing exactly where a thrown ball will land before it even leaves your hand. And this level of precision is not just limited to large objects like planets. It also applies to the tiniest particles, the building blocks of matter, which behave in ways that follow consistent mathematical rules, like a complex dance where every step is guided by an invisible structure. And here's something many people don't realize. These laws seem to be the same everywhere in the universe, whether you are here on Earth or in a galaxy billions of light years away. And to help picture that distance, imagine traveling at the speed of light, which is so fast it could circle the Earth more than 7 times in just 1 second. And even at that speed, reaching some distant galaxies, would take longer than the entire history of human civilization, multiplied thousands of times, and yet the same basic laws appear to apply there as they do here, and that raises a gentle question. Why are these laws universal? Why don't they vary from place to place, like weather changing from one city to another? And some might think that these laws are just descriptions of what we observe, not something that exists on their own. And that's partly true, because we create the formulas and equations to describe what we see, but the patterns themselves, the consistency in how things behave, seem to be built into reality itself. And you might wonder, are these laws something that was set at the beginning of the universe, like rules written before a game begins? Or did they emerge naturally as the universe formed, like patterns that appear when certain conditions come together? And at the moment, we don't have a complete answer. But what we do know is that, without these laws, the universe would look very different. Stars might not form, atoms might not hold together, and life as we know it would not exist. It would be like trying to build a house with no structure, where nothing stays in place long enough to form anything stable. And yet, here we are in a universe where structure is not only possible, but common, where simple particles come together to form atoms. Atoms form molecules, molecules form cells, and cells eventually form living beings, all following the same underlying rules. And this leads to another quiet thought, that the laws of physics are not just abstract ideas. They are the reason anything can exist in a stable way at all. They are like the invisible framework that holds everything together, like the unseen rules that allow a story to unfold in a way that makes sense. And you might gently ask yourself, why these laws and not others? Why do they have the specific form they do? And this question doesn't yet have a clear answer. Some suggest that there may be deeper laws that give rise to the ones we know, while others think that the laws we observe might be just one possibility among many. And we happen to be in a universe where they allow for complexity and life. And as you sit with this idea, the universe begins to feel less random and more structured, like a vast system that follows a consistent logic, even if we don't fully understand where that logic comes from. And in that sense, the existence of these laws becomes something quietly remarkable, because they are not just rules we discovered. They are the very reason discovery is possible at all. They are what make the universe understandable, at least in part. And that understanding allows us to ask deeper questions, to explore further, and to continue this gentle journey of curiosity, where each answer leads to another question, and each question opens a new window into the mystery of existence itself. As the idea of these steady and reliable laws settles in, a deeper question slowly rises, almost like a quiet ripple beneath the surface. And that question is this: where did these laws come from? Because it's one thing to notice that the universe follows rules, but it's another thing entirely to ask why those rules exist at all. And you might begin by thinking about rules in everyday life, like the rules of a game, which are usually created by someone, written down, agreed upon, and followed, so that the game can work. And that comparison feels natural at first. But then you might pause and wonder, does that mean the laws of physics were also set by something or someone? Or are they different, in a more fundamental way? And this is where things become more subtle, because unlike the rules of a game, the laws of physics are not written anywhere we can see. They don't exist as words or instructions. They are more like patterns that describe how reality behaves, like noticing that waves always move in a certain way on the surface of water. And so the question becomes, are these patterns simply there, part of reality itself? Or do they come from something deeper, something we have not yet discovered? And some scientists believe that the laws we know might not be the most basic layer, that there could be deeper rules underneath, like a hidden foundation that gives rise to everything else, and you might imagine it like layers of a structure, where what we see on the surface is supported by something below, and that something might be supported by something even deeper, and so on, like peeling back layers of an onion. And yet, even if we find deeper and deeper laws, the question still remains, where did the very first layer come from? The most basic rule of all. And this is where our understanding begins to reach its limits, because we are so used to thinking in terms of cause and effect that we naturally expect an answer, something that explains the origin of these laws. But it's possible that the laws of physics are not something that were created in the way we usually imagine. They might simply exist as part of the nature of reality, something that does not require a cause outside itself. And that idea can feel a bit strange, almost like trying to accept that a story has no author, that it simply exists as it is. And you might ask, is that even satisfying? Or does it leave something unanswered? And for many people, it does leave a sense of openness, a feeling that there is still more to understand. And this is where different perspectives begin to appear. Some suggest that the laws of physics might be the result of deeper mathematical truths, that reality follows mathematics, because mathematics is somehow built into the fabric of existence, like a hidden language that everything naturally speaks. And that raises another gentle question. Why would mathematics exist in such a way that it describes reality so well? Why should numbers and patterns match the behavior of the physical world so closely? And others suggest that there could be many possible sets of laws, and we happen to exist in a universe where the laws allow for stability and complexity, and you might picture it like trying many different combinations of rules until one creates a world where structures can form, where stars can shine, where life can emerge, and we find ourselves in that particular version, because it is one of the few where observers can exist at all. And still, even with these ideas, the question doesn't fully disappear. It simply becomes quieter, more open, like a door that remains slightly ajar, inviting further thought. And as you sit with this, you might notice that the laws of physics begin to feel less like fixed instructions and more like a deep order woven into everything, like the rhythm of a song that continues whether or not anyone is listening. And that rhythm allows everything to unfold in a consistent way, from the smallest particles to the largest galaxies, and it is this consistency that makes understanding possible, that allows us to learn, to predict, to explore, and to ask these questions in the first place. And perhaps that is part of what makes this so fascinating. Not just that the laws exist, but that they are stable enough for us to notice them, to study them, to reflect on them, and to wonder about their origin. And even if we do not yet have a final answer, the question itself becomes something meaningful, something that connects us to the deeper structure of reality, because in asking where the laws of physics come from, we are really asking about the foundation of everything, the quiet framework that holds the universe together. And in that sense, the question is not just about science. It is about existence itself, about why anything behaves the way it does, and why there is order instead of complete chaos. And as this thought gently settles, it leaves us with a sense of curiosity that does not need to be rushed, a sense that there is still more to discover, more to understand, and more to explore, like standing at the edge of a vast landscape, knowing that beyond what we can currently see, there are still endless possibilities waiting to be uncovered, quietly inviting us to keep wondering and to keep asking where it all comes from and why it is the way it is. As the quiet question about the origin of these laws lingers in the background, another detail begins to come into focus, something that at first might seem small, almost like a technical detail, but the more you look at it, the more surprising it becomes. And that is the idea that the universe appears to be finely balanced in a very precise way, a balance so delicate that even tiny changes could lead to a completely different reality. And you might ask, what does that really mean? How precise are we talking about? And one way to picture it is to imagine a control panel filled with dials, each one representing a different aspect of the universe, like the strength of gravity, the behavior of particles, or the rate at which space expands. And now imagine that each of these dials has to be set to a very specific value, not too high and not too low. Because if even one of them is slightly off, the universe as we know it would not be able to form. It would be like trying to tune a radio to a very specific station, where moving the dial just a tiny bit causes the signal to fade into noise. And this idea is often called fine-tuning, and it suggests that the universe is not just randomly set, but carefully balanced in a way that allows for structure, complexity, and eventually life. And many people don't realize just how sensitive this balance is, because we tend to assume that things could vary a little without much consequence. But in the case of the universe, even very small differences can have huge effects, like adjusting the ingredients in a recipe by just a tiny amount and ending up with something completely different. And you might wonder, is this really true? Or is it just an exaggeration? And while there is still ongoing discussion about the details, many scientists agree that certain constants, like the strength of gravity or the forces that hold atoms together, need to fall within a narrow range for stars and planets to form. And without stars, there would be no light, no heat, no way to create the elements needed for life. It would be like trying to build a city without any materials. Nothing would come together in a stable way. And this leads to a gentle but important question. Why is the universe set up this way? Why do these values fall within the range that allows for everything we see? And there are a few different ways people think about this. Some suggest that it may just be a coincidence, that out of many possible ways the universe could have been, we happen to be in one that works. And that idea can feel a bit like winning a lottery with incredibly low odds, where the chances are so small that it almost feels surprising that it happened at all. And others suggest that there might be many universes, each with different settings, and we find ourselves in one that supports life, simply because we could not exist in any of the others. And you might picture it like trying many different combinations on that control panel, with most of them leading to empty or unstable universes, and only a few creating something rich and structured. And we are naturally in one of those few, because otherwise we would not be here to notice it. And still, there are those who see this fine balance and feel that it points to something deeper, something intentional, as if the universe is not just randomly set, but arranged in a way that allows for complexity and awareness to emerge. And that idea raises its own set of questions, because if the universe is finely tuned, what or who could have tuned it, and how would that even work? And these are not questions with simple answers, but they are questions that have been explored by thinkers for a long time, across science, philosophy, and even theology. And as you sit with this idea, the universe begins to feel a little different, not just vast and mysterious, but also delicate in a way, like a balance that could have easily been otherwise. And you might gently ask yourself, if even small changes could prevent the formation of stars or atoms, then how did everything come together in just the right way? And is that something that needs an explanation, or is it simply the way things are? And there is no need to look beyond it. And this is where the fine-tuning problem becomes less about finding a final answer and more about recognizing the depth of the question, because it invites us to look at the universe not just as something that exists, but as something that exists in a very specific and precise way, a way that allows for structure, for complexity, and for beings like us to emerge and ask these very questions. And in that sense, the fine balance of the universe becomes part of the larger mystery, a quiet reminder that there is still much we do not fully understand, and that the more we learn, the more we uncover layers of complexity that continue to inspire curiosity and wonder, like discovering that behind what once seemed simple, there is an intricate pattern waiting to be explored, gently inviting us to keep looking, to keep asking, and to keep reflecting on the remarkable nature of the universe we find ourselves in. As we stay with this idea of a finely balanced universe, it can help to slow down and look more closely at what would happen if even one of those settings were changed, just slightly, almost like turning a dial by the smallest amount. And you might wonder, would it really make that much of a difference? Would the universe truly change in a dramatic way, or would it still look mostly the same? And the surprising answer is that even tiny changes could lead to a completely different outcome, so different that the universe we know might not exist at all. And to picture this, imagine you are baking something simple, like bread, where the ingredients need to be in the right proportions, not perfectly exact, but close enough for the process to work. And now imagine adding just a little too much salt, or removing just a little too much water, and suddenly, the bread doesn't rise the same way. It becomes dense or falls apart. And now take that idea and stretch it to a much larger scale, where instead of bread, we are talking about stars, galaxies, and the building blocks of matter. And in this case, the balance is far more sensitive, like trying to balance a pencil on its tip, where even the smallest shift causes it to fall. And one example often discussed is the strength of the forces that hold atoms together. Because atoms are the foundation of everything we see, from the air you breathe to the ground beneath your feet. And if these forces were even slightly weaker, atoms might not hold together at all. They would fall apart before they could form anything stable. And that would mean no molecules, no chemistry, no life. It would be like trying to build a house out of sand that refuses to stick together. And on the other hand, if those forces were slightly stronger, atoms might bind too tightly, preventing the kinds of reactions needed to create complex structures. It would be like having pieces of a puzzle glued together in the wrong way, making it impossible to form the full picture. And you might ask, how small are these changes we're talking about? And while the exact numbers can be complex, the key idea is that the range of values that allow for a life-friendly universe appears to be quite narrow, like a narrow path on a mountain ridge where stepping too far to either side leads to a completely different landscape. And this idea extends beyond atoms to other aspects of the universe as well, including the rate at which the universe expands. Because if the expansion had been just a little faster in the beginning, matter would have spread out too quickly for gravity to pull it together into stars and galaxies. It would be like trying to gather drops of water that are being flung outward in every direction, never coming together to form anything larger. And if the expansion had been just a little slower, gravity might have pulled everything back together too quickly, leading to a collapse before stars had a chance to form, like a balloon that begins to inflate but then suddenly shrinks before it can take shape. And these examples gently show how sensitive the universe is to its initial conditions. And you might begin to wonder, is this level of sensitivity unusual, or is it something we would expect? And that question does not yet have a simple answer, because it depends on how we think about the possible ways the universe could have been. And some people assume that small changes should not matter much, because in everyday life, we often see systems that can handle a bit of variation, like a car that still runs, even if one part is slightly worn. But at the level of the entire universe, the balance appears to be more delicate, more like a precise combination, where each part plays a critical role. And as you sit with this, it can lead to another quiet question. Why do these constants fall within this narrow range? Why are they not slightly different? And is there something that determines their values, or are they simply the result of chance? And different ideas offer different perspectives. Some suggest that there may be many universes with different constants, and we happen to be in one where the values allow for complexity, while others wonder if there might be deeper principles that fix these values in place, something that makes them what they are, and not otherwise. And as these possibilities gently unfold, the universe begins to feel even more remarkable, not just because it exists, but because it exists in a way that allows for structure, for stars to shine, for planets to form, and for life to emerge. And you might notice that this does not immediately lead to a single conclusion, but instead opens a space for reflection, a space where different ideas can be considered without rushing to decide which one is correct. And in that space, the sensitivity of the universe becomes something to appreciate, something that adds depth to our understanding, like realizing that behind something that seems stable and familiar, there is a delicate balance quietly holding it all together. And in that sense, the question of what would happen if constants were slightly different becomes less about imagining alternative universes and more about noticing the one we are in, a universe where everything has come together in just the right way for us to be here, thinking about it, wondering about it, and gently exploring the mystery that surrounds us. As we continue to gently explore this delicate balance, one of the most important pieces to look at is something we experience every day without really thinking about it. And that is gravity, the quiet force that pulls everything toward everything else, keeping your feet on the ground, holding the oceans in place, and guiding the motion of planets and stars across space. And you might pause and ask, what exactly would happen if gravity were just a little different? Would it really matter that much? And to begin to picture this, imagine gravity as a kind of invisible pull between objects, like a soft but constant tug. And right now, here on Earth, that pull is strong enough to keep you grounded, but not so strong that you feel crushed. It's balanced in a way that feels natural, like holding a light backpack that has some weight but doesn't slow you down too much. And now imagine if gravity were much stronger, even just a few times stronger than it is now, and suddenly your own body would feel much heavier, like carrying several large bags at once all the time. Walking would become difficult, jumping might be nearly impossible, and over time, living things might not be able to grow tall or move easily, because the constant pull would make it too hard to support larger structures. And this effect doesn't just apply to life on planets, it also affects how stars form and behave, because gravity is what pulls gas and dust together to form stars in the first place, like slowly gathering clouds into a dense cluster. And if gravity were much stronger, this process would happen very quickly, causing stars to form rapidly and burn through their fuel much faster, like a candle that burns too brightly and runs out in a short time. And that would mean stars might not last long enough to support the slow processes needed for planets and life to develop. And on the other hand, if gravity were weaker, even slightly weaker, the opposite problem would appear. Matter would have a harder time coming together at all. Gas and dust might drift apart instead of clumping together, like trying to gather sand that keeps slipping away from your hands. And in that case, stars might not form in large numbers, or they might not form at all, leaving the universe dark and scattered, without the bright points of light that we see in the night sky. And you might wonder, how sensitive is this balance? How much would gravity need to change for these effects to happen? And while the exact numbers can be complex, the key idea is that gravity plays a crucial role in shaping the structure of the universe, and even moderate changes could lead to a very different outcome, because it influences not just one thing, but many connected processes, from the formation of stars to the motion of galaxies and even the stability of planetary systems. And to help picture this on a larger scale, imagine the solar system as a carefully arranged dance, where planets move around the sun in steady paths, guided by gravity. And if that pull was slightly stronger, planets might spiral inward over time, moving closer and closer until their environments change dramatically. And if it were weaker, planets might drift away, losing their stable paths and moving into colder, darker regions of space. And in both cases, the conditions needed for life could be disrupted. And this leads to a gentle question: why does gravity have the strength that it does? Why is it not stronger or weaker? And like many of the constants we've been considering, we do not yet have a complete answer, but we can see that its current value allows for a universe where structures can form and remain stable over long periods of time. And that stability is important because life as we know it depends on time. It depends on processes that unfold slowly, like the formation of stars, the creation of elements, and the development of complex systems. And without that time, without that balance, the story of the universe would look very different. And as you sit with this idea, gravity begins to feel less like a simple force and more like a key part of a larger balance, something that quietly shapes everything from the smallest scales to the largest, like an invisible thread, woven through the fabric of reality, holding things together in just the right way. And you might notice that this does not mean gravity is special on its own, but that it works together with other forces, each playing its part in maintaining the overall structure of the universe. And in that sense, the strength of gravity becomes another piece of the larger picture, a reminder that the universe is not just a collection of random events, but a system where many elements interact in a balanced way. And even if we do not yet fully understand why gravity has the value it does, we can see how important that value is, how it allows for the formation of stars, the stability of planets, and the conditions that make life possible. And in that quiet realization, the familiar feeling of gravity, something we experience every moment, becomes part of a much deeper story, one that connects us to the larger structure of the universe and invites us to keep wondering about how everything fits together in such a precise and meaningful way. As we continue to notice how gravity plays its part in shaping the universe, it becomes clear that it is not acting alone. And this leads us to another quiet realization, that the universe is guided not by one force, but by several, each with its own role, each interacting with the others in a delicate balance. And you might gently ask, what are these forces and how do they work together? And in simple terms, there are four fundamental forces that scientists talk about: gravity, which we've already explored; the electromagnetic force, which is responsible for light and electricity and holds atoms together; the strong nuclear force, which binds particles inside the center of atoms; and the weak nuclear force, which plays a role in certain types of particle changes. And at first, these might sound like abstract ideas, but they are actually involved in everything around you, from the light you see to the matter that makes up your body. And you might wonder, what would happen if even one of these forces was slightly different? Would the universe still function in the same way? And to begin to picture this, imagine a group of musicians playing together in a quiet performance, each one contributing a different sound, and when they are in balance, the music flows smoothly. But if one instrument becomes too loud or too quiet, the harmony begins to break, and the overall experience changes. And in a similar way, these forces must be balanced in relation to each other, not just individually, but in how they compare and interact. And one example of this balance can be seen inside atoms, where the electromagnetic force pulls negatively charged electrons toward the positively charged center, while other effects prevent them from collapsing completely, allowing atoms to have structure like a tiny system, where parts remain stable instead of falling inward. And at the same time, the strong nuclear force holds together particles inside the atomic center, overcoming the natural repulsion between positively charged components. And if this force were slightly weaker, the center of atoms might not hold together at all, causing matter to fall apart at its most basic level. Like trying to hold a handful of sand that keeps slipping through your fingers, and if it were slightly stronger, particles might bind too tightly, preventing the kinds of interactions needed for more complex structures to form. And you might ask, how precise does this balance need to be? And while the exact details are still studied, the important idea is that these forces must fall within certain ranges relative to each other because they are constantly interacting, like multiple dials that must be set in coordination, not just individually. And this balance also affects processes in stars, where nuclear reactions depend on the strength of these forces, allowing stars to shine steadily over long periods of time. And to picture this, imagine a steady flame that burns at just the right intensity, not too fast and not too slow, providing warmth and light over time. And if the balance were different, that flame might either burn out quickly or fail to ignite properly. And in the same way, stars rely on a careful interaction of forces to maintain their structure and energy output. And without that balance, the universe would look very different, either too unstable or too simple to support the complexity we see today. And this leads to a gentle question: why do these forces have the strengths they do? And why are they balanced in this particular way? And like many of the questions we've been exploring, there is no single answer that fully explains it yet. But there are ideas some suggest that these forces may have been unified in a single framework at the very beginning of the universe, and then separated as the universe expanded and cooled, like a single color spreading into different shades. And others explore the possibility that different universes might have different balances of forces, with only certain combinations allowing for stable structures. And we find ourselves in one of those combinations. And as you sit with this idea, the universe begins to feel more like a system of relationships rather than isolated parts, where everything is connected through these interactions, and where balance is not just a feature, but a necessity. And you might notice that this balance is not something we directly see, but something we infer from the behavior of matter and energy, like noticing the steady rhythm of a heartbeat without seeing the heart itself. And in that sense, the balance of forces becomes part of the deeper structure of reality, something that quietly shapes everything from the smallest particles to the largest galaxies. And even if we do not yet fully understand why this balance exists, we can see how important it is, how it allows for stability, for change, for growth, and for the emergence of complex systems. And this realization gently adds another layer to our understanding, showing that the universe is not just held together by individual forces, but by the way those forces work together in harmony, like a quiet coordination that makes everything possible. And in that harmony, we find yet another reason to pause, to reflect, and to continue wondering about how such a balance came to be and what it might reveal about the deeper nature of existence itself. As we continue to explore how the universe is shaped by these forces and balances, another quiet mystery begins to appear, something that we cannot see directly, and yet it seems to be everywhere, gently influencing the structure of the cosmos. And this is what scientists call dark matter. And you might wonder, what exactly is dark matter? Is it some kind of invisible substance, or is it something entirely different? And the simple answer is that we don't fully know yet, but we do know that it behaves like matter in one important way. It has gravity, it pulls on things, it affects how galaxies move, even though we cannot see it with our eyes or detect it in the usual ways. And that might sound strange at first, like saying there is something there that we cannot touch or see, and yet we know it exists because of the way it affects everything else. And to picture this, imagine watching leaves floating on the surface of a pond, and suddenly you notice that they begin to move in a certain pattern, swirling around as if something beneath the water is guiding them. Even though you cannot see what is underneath, you can tell that something is there because of the motion it creates. And in a similar way, scientists observe how stars move within galaxies, and they notice that the visible matter alone is not enough to explain the motion, because stars at the edges of galaxies move faster than expected, almost as if there is extra mass holding everything together, like a hidden weight that keeps the system from flying apart. And this extra mass is what we call dark matter. And you might ask, how much of it is there? And surprisingly, it seems to make up a large portion of the universe, far more than the matter we can see, so much that if you could somehow weigh everything in the universe, dark matter would outweigh visible matter by several times, like having a backpack where most of the weight comes from something you cannot see or feel directly. And this leads to another gentle question. What is dark matter made of? And this is where the mystery deepens. Because unlike ordinary matter, which is made of atoms, dark matter does not seem to interact with light. It does not absorb it, reflect it, or emit it, which is why it remains invisible. And scientists have proposed different possibilities, such as new kinds of particles that we have not yet detected, particles that pass through ordinary matter almost without interaction, like tiny invisible travelers, moving through everything around us without leaving a trace. And experiments have been designed to try to detect these particles, often placed deep underground, to reduce interference. But so far, the results have not given a clear answer. And you might wonder, if we cannot see it or touch it, how confident are we that it exists at all? And this is a fair question, because in science, evidence is important. And while we cannot observe dark matter directly, the evidence for its effects is strong, coming from many different observations, from the motion of galaxies to the way light bends around massive objects, something known as gravitational lensing, where light from distant sources is curved as it passes through regions with large amounts of mass, including dark matter. And to picture this, imagine looking through a piece of glass that slightly distorts what you see behind it, bending the image in subtle ways. And in the same way, dark matter bends light, revealing its presence through the patterns it creates. And as you sit with this idea, the universe begins to feel even more layered, not just made of what we can see, but also of what we cannot, like a story with hidden chapters that still influence the overall plot. And you might gently ask, why does dark matter exist? What role does it play in the larger picture? And while we do not yet have a complete answer, it appears to be important for the formation of galaxies, acting like a kind of invisible framework that helps matter come together, like a scaffold that supports the construction of a building, guiding how structures form and evolve over time. And without it, the universe might look very different, with fewer galaxies or less organized structures. And this realization adds another layer to the mystery, because it shows that there are aspects of the universe that we are only beginning to understand, things that challenge our usual ways of thinking and invite us to look deeper. And as you reflect on this, you might notice that the presence of dark matter does not make the universe feel less understandable, but more intriguing, more open to discovery, because it reminds us that there is still more to learn, more to uncover, and more to explore. And in that sense, the mystery of dark matter becomes part of the larger journey, quiet reminder that even in a universe governed by laws and patterns, there are still hidden pieces waiting to be revealed, gently encouraging us to keep asking questions and to remain curious about the unseen forces that shape everything around us. As we sit with the idea that much of the universe is made of something we cannot see, another even more surprising discovery begins to unfold, something that changes not just how matter gathers, but how the entire universe behaves on the larger scale. And this is what scientists call dark energy. And you might wonder, what is dark energy, and how is it different from dark matter? And while dark matter pulls things together through gravity, dark energy appears to do something very different. It seems to push things apart, causing the universe to expand at an increasing rate. And that might sound a bit confusing at first, because we often imagine gravity as the main force shaping the cosmos, pulling galaxies toward each other, slowing things down over time, like throwing a ball upward, and watching it gradually fall back down. And for a long time, scientists expected the expansion of the universe to slow in a similar way, gradually easing as gravity worked to pull everything back together. But when they looked more closely at distant galaxies, they found something unexpected. Those galaxies were not slowing down. They were moving away faster and faster, like dots on a balloon, that not only expand outward, but begin to separate more quickly as the balloon inflates. And this discovery was surprising because it suggested that there is something counteracting gravity on the largest scale, something that is gently pushing space itself to expand more rapidly over time. And this is what we call dark energy. And you might ask, how strong is this effect? And to picture it, imagine placing small objects on a stretchy surface, like a piece of fabric, and slowly pulling the fabric outward, causing the objects to drift apart. And now imagine that the stretching becomes faster over time, so that the objects move away from each other more quickly the longer the process continues. And that gives a rough sense of how dark energy affects the universe, not by pushing objects through space, but by stretching space itself. And this leads to another gentle question: how much of the universe is made of dark energy? And surprisingly, it appears to make up the majority, even more than dark matter, and far more than the ordinary matter we are familiar with. So if you imagine dividing the universe into parts, most of it would be this mysterious energy driving expansion, while only a small portion would be the visible matter that forms stars, planets, and everything we can directly observe. And that realization can feel a bit surprising, because it means that what we see is only a small part of the whole, like looking at the surface of an ocean, while most of its depth remains hidden below. And you might wonder, what exactly is dark energy made of? And here again the answer is that we do not yet know. It is one of the biggest mysteries in modern science, and different ideas have been proposed. Some suggest that it could be a property of space itself, that empty space has a kind of energy that causes it to expand, while others explore different possibilities, including new types of fields or effects that we have not yet fully understood. And as you sit with this, you might ask, why does dark energy exist at all? Why should the universe not simply expand at a steady rate or slow down over time? And this question does not yet have a clear answer, but it adds another layer to the larger picture, showing that the universe is not only structured and balanced, but also dynamic, changing in ways that we are still trying to understand. And you might gently consider what this means for the future. If the expansion continues to accelerate, what will happen over very long periods of time? And one possibility is that galaxies will move farther and farther apart, eventually becoming so distant that they are no longer visible from one another, like islands drifting apart in a vast ocean, each becoming more isolated over time. And while this happens on timescales far beyond human experience, it still gives us a sense of how the universe evolves, how it changes slowly and steadily, guided by forces and energies that operate on scales we can barely imagine. And to help picture the size of this change, imagine a distance so large that even light traveling faster than anything else, takes millions or billions of years to cross it. And now imagine that distance, growing larger as time goes on, stretching further and further. And in that sense, dark energy becomes part of the story of the universe's expansion, a quiet force shaping its future. And as you reflect on this, the universe begins to feel even more mysterious, not just because of what we do not see, but because of how much of it is made of things we are still trying to understand. And yet, even with these unknowns, we are able to observe patterns, to measure changes, and to piece together a picture of what is happening. And that in itself is something remarkable, because it shows that even in a universe filled with mysteries, there is still a way to learn, to explore, and to gently uncover the deeper structure of reality. And in that sense, the role of dark energy becomes not just a scientific question, but part of a larger journey, one that invites us to keep wondering about how the universe works, how it changes, and what it might reveal as we continue to look deeper and think more carefully about the quiet forces shaping everything around us. As we slowly take in the presence of these hidden components, dark matter shaping structure and dark energy guiding expansion, another gentle observation begins to emerge, something that feels almost familiar but becomes more surprising the longer we sit with it. And that is the simple fact that the universe shows a deep sense of order, a kind of structure that appears again and again across different scales, from the smallest patterns to the largest formations. And you might pause and ask, what does it really mean for the universe to have order? Because at first glance, it can seem like everything is random, like stars scattered across the sky without any clear pattern. But when we look more closely, we begin to notice that there are shapes, systems, and repeating forms, like galaxies, that spiral in similar ways, clusters that group together, and structures that stretch across space, like a vast web. And to picture this, imagine looking at a city from above, at night, where at first it might look like a random collection of lights, but as your eyes adjust, you begin to see roads, neighborhoods, and patterns of movement. And in a similar way, the universe reveals its structure the more carefully we observe it. And this raises a quiet question. Why is there order at all? Why does the universe not remain in complete chaos, where everything is scattered without any stable arrangement? And part of the answer comes from the laws and forces we have been exploring, because they guide how matter and energy behave, allowing structures to form and persist over time. But even with these laws, the emergence of such large-scale patterns can still feel surprising, because it involves many layers working together, like simple rules leading to complex outcomes. And you might wonder, how does that happen? How does something simple lead to something so detailed and organized? And one way to think about it is to imagine a small set of instructions being repeated over and over again, like stacking blocks in a certain way, where each step is simple, but over time, a larger structure begins to appear. And in the universe, small differences in density, tiny variations in how matter was distributed in the early moments, began to grow over time, guided by gravity and other forces, eventually forming galaxies, stars, and planets. And to help picture this, imagine a slightly uneven surface, where some areas are just a bit higher than others. And as time passes, those high areas collect more material, growing larger and more defined, while the lower areas become emptier. And this gradual process leads to the patterns we see today. And yet, even with this explanation, there is still something quietly remarkable about the level of order that emerges, because it is not just about structure, but about stability, about systems that can exist for long periods of time without falling apart, like stars that shine steadily for billions of years. or planetary systems that maintain their paths with gentle consistency. And you might ask, is this kind of order inevitable, or is it something special about our universe? And this is a question that continues to be explored, because it touches on deeper ideas about how complexity arises from simplicity, and whether the patterns we see are the result of underlying principles, or simply the outcome of initial conditions playing out over time. And as you sit with this, you might notice that the universe feels less like a random collection of events, and more like a connected system where different parts influence each other, where patterns repeat and evolve, and where order emerges naturally from the interaction of simple rules. And this does not mean that everything is perfectly ordered, because there is still randomness, still unpredictability, still areas where things do not follow a clear pattern. But within that mix of order and variation, something stable and meaningful appears, like a balance between structure and freedom. And you might gently reflect on how this order allows for the existence of everything we see, because without it, matter would not come together, systems would not form, and the universe would remain a scattered and simple place. And in that sense, the presence of order becomes another piece of the larger picture, a quiet reminder that the universe is not just vast, but also structured in a way that allows for complexity, for growth, and for the emergence of systems that can observe and reflect on their own existence. And as this thought settles, it invites a sense of calm curiosity, a feeling that there is a deeper pattern woven into everything, even if we do not fully understand it yet, and that by continuing to observe, to question, and to explore, we can slowly begin to see more of that pattern, more of that order, and more of the quiet structure that shapes the universe around us and within us at the same time. As we continue to notice this quiet order woven through the universe, another gentle realization begins to take shape, something that might feel almost surprising at first. And that is the idea that this order can be described using mathematics. Simple patterns of numbers and relationships that seem to match the behavior of the physical world with remarkable accuracy. And you might pause and wonder, why mathematics? Why should something as abstract as numbers and equations be able to describe something as real and tangible as the universe? And to begin to picture this, imagine drawing a simple curve on a piece of paper, a smooth line that rises and falls, and then imagine that same curve describing the path of a planet moving through space, or the motion of a wave in the ocean, or even the way light bends as it travels. And suddenly, that simple drawing becomes a kind of map, a way of understanding something much larger. And this is what mathematics does. It provides a language that captures patterns in a precise and consistent way, allowing us to describe how things move, how they interact, and how they change over time. And you might ask, how accurate is this description? And the answer is, often incredibly accurate. So much so that we can predict events far into the future, like knowing where a planet will be years from now, or how a signal will travel across space, almost like being able to predict the exact path of a thrown ball before it leaves your hand. And this level of accuracy is not limited to large objects. It also applies to the smallest scales, where particles behave according to mathematical rules that can be described with detailed formulas. And this leads to a quiet question. Is mathematics something we invented, or is it something we discovered? Because if it were purely invented, it might not match reality so well. It would be like creating a language that only works in our imagination. But the fact that mathematics describes the universe so precisely suggests that it is uncovering something real, something that exists independently of us, like finding patterns in nature that were always there waiting to be noticed. And many people find this idea both fascinating and a little mysterious, because it raises the question of why the universe follows mathematical patterns at all. Why should reality be structured in a way that can be expressed through numbers and relationships? And to help picture this, imagine listening to music where each note follows a certain pattern, creating harmony and rhythm. And now imagine being able to write down those patterns in a way that captures the entire song. And mathematics is a bit like that, a way of writing down the patterns of the universe so that we can understand and explore them. And yet, even with this powerful tool, there are still limits to what we can describe. There are areas where our current mathematics does not fully capture what is happening, especially in extreme conditions like the very beginning of the universe or inside certain regions of space. And this reminds us that while mathematics is incredibly useful, it may not be the complete picture. It may be part of a larger framework that we are still uncovering. And you might gently ask, does this mean the universe is fundamentally mathematical? Or does it simply behave in ways that can be described mathematically? And this is a question that has been explored for a long time, with different perspectives offering different answers, some suggesting that reality itself is deeply connected to mathematical structures, while others see mathematics as a tool that helps us describe patterns without necessarily being the foundation of those patterns. And as you sit with this idea, the universe begins to feel even more interconnected, not just through physical forces and structures, but through patterns that can be expressed in a precise and elegant way, like a hidden language that runs through everything, from the motion of galaxies to the behavior of particles. And you might notice that this does not make the universe feel less mysterious, but in some ways more so, because it suggests that behind what we observe, there is a deeper level of order that we are only beginning to understand. And yet, even with all the questions that remain, the fact that mathematics works so well allows us to explore the universe in ways that would otherwise be impossible. It allows us to make predictions, to test ideas, and to slowly build a picture of how everything fits together. And in that sense, the mathematical nature of the universe becomes part of the larger journey, quiet reminder that there is a structure underlying everything, a structure that can be described, explored, and appreciated, even if we do not yet fully understand why it exists in the first place. And as this thought settles, it invites a sense of calm curiosity, a feeling that there is still more to discover, more patterns to uncover, and more connections to explore, like following a path that continues to unfold the further we walk, gently revealing the hidden order that shapes the universe around us. As we gently sit with the idea that the universe can be described through mathematics, another question quietly begins to form, one that feels simple on the surface, but becomes deeper the more you think about it. And that question is this: why does mathematics work so well in the first place? Why should patterns of numbers and symbols match the behavior of the real world with such precision? And you might start by thinking about how mathematics appears in everyday life, like counting objects, measuring distances, or noticing patterns. And in those cases, it makes sense, because we are using math to describe things we can see and touch. But when it comes to the universe as a whole, the level of accuracy becomes much more surprising, because the same mathematical ideas that describe simple objects can also describe the motion of planets, the behavior of light, and even the structure of space itself. And you might pause and wonder, is this just a coincidence? Or is there something deeper, connecting mathematics and reality? And to begin to picture this, imagine creating a set of rules for a game, simple rules that define how pieces move and interact, and then discovering that those same rules can also describe something completely different, like patterns in nature or the flow of water, and that would feel unexpected, like finding that a small idea applies to something much larger than you first thought. And in a similar way, mathematics seems to apply across many different areas, linking them together in a consistent way. And this leads to a gentle question: does the universe follow mathematics? Or does mathematics simply describe the patterns we observe? And the answer is not entirely clear, because it depends on how we think about both concepts. Some people see mathematics as a kind of discovery, something that exists independently of us, like a hidden structure that we uncover over time, while others see it as a tool we create to describe what we see, a language that becomes more refined as we learn more about the world. And you might ask, if mathematics is just a tool, why does it work so perfectly? Why does it not break down when we apply it to different parts of the universe? And this is where the mystery deepens, because the effectiveness of mathematics goes beyond what we might expect from a simple tool. It allows us to make predictions that can be tested and confirmed, sometimes in ways that were not even imagined when the mathematics was first developed, like creating a formula and later discovering that it describes a real phenomenon we had not yet observed. And to help picture this, imagine drawing a map based on patterns you notice, and then finding out that the map accurately shows places you have never visited, almost as if the map already contained information about those places before you explored them. And in a similar way, mathematics sometimes reveals aspects of the universe that we only later confirm through observation. And this can feel both fascinating and puzzling, because it suggests a deeper connection between abstract ideas and physical reality. And you might gently wonder, why should such a connection exist at all? Why should the universe be structured in a way that aligns with mathematical patterns? And while there is no single answer that fully explains this, there are different perspectives. Some suggest that the universe itself might be fundamentally mathematical, that its structure is inherently based on relationships that can be expressed through numbers, while others suggest that mathematics works because it captures the regularities in how things behave, and those regularities are what we observe as laws and patterns. And as you sit with this idea, the boundary between mathematics and reality begins to feel less clear, more like two aspects of the same underlying structure, rather than separate things. And you might notice that this does not remove the mystery, but instead adds another layer to it, because it raises questions about the nature of both mathematics and the universe, and how they relate to each other. And yet, even without a final answer, the fact that mathematics works so well allows us to explore the universe in a meaningful way. It gives us a way to describe, to predict, and to understand, even if that understanding is not complete. And in that sense, the effectiveness of mathematics becomes something to appreciate, something that connects our thoughts to the structure of reality, like a bridge between what we imagine and what exists. And as this thought gently settles, it invites a sense of quiet curiosity, a feeling that there is still more to discover, more connections to explore, and more questions to ask about why mathematics fits the universe so well, and what that might reveal about the deeper nature of existence itself. And in that ongoing exploration, we find ourselves not just observing the universe, but also participating in the process of understanding it, using patterns and ideas that somehow align with the very structure we are trying to comprehend. As we continue to reflect on how simple rules and patterns seem to shape the universe, another quiet and fascinating idea begins to unfold, and that is how complexity can emerge from simplicity, how something incredibly detailed and rich can grow out of basic building blocks. And you might pause and ask, how does that even happen? How do simple particles and forces give rise to something as complex as galaxies, planets, and even living beings? And to begin to picture this, imagine starting with a few simple pieces, like small blocks, and arranging them in different ways. At first, the structures you create might be simple, just a few shapes stacked together. But as you keep building, combining, and rearranging, those simple pieces can form more intricate patterns, eventually becoming something much larger and more detailed, like a small model that grows into a complex structure. And in the universe, this process begins with the simplest components, tiny particles that follow basic rules, interacting with each other through forces like gravity and electromagnetism. And over time, these interactions lead to the formation of atoms. And atoms come together to form molecules, and molecules can combine in countless ways, creating a wide range of materials and structures. And you might wonder, how long does this process take? And the answer is, a very long time. Billions of years, like watching a slow transformation, where each step builds on the previous one, almost like a story that unfolds gradually, one chapter at a time. And to help picture the scale of this, imagine a process so slow that if you compared it to a single day, the entire history of human civilization would be just a tiny moment, like a few seconds before midnight. And yet, over this immense span of time, simple beginnings lead to incredible complexity, from the formation of stars and galaxies to the creation of planets with diverse environments, and eventually, in some places, the emergence of life. And this leads to a gentle question: is complexity something that naturally arises, given enough time and the right conditions? Or is there something special about the way our universe is set up that allows it to happen? And this is a question that continues to be explored, because while we can observe how complexity develops, understanding why it develops in this particular way is still an open area of curiosity. And you might notice that complexity is not just about size or number, but about organization, about how parts come together to form systems that have new properties that are not present in the individual parts alone, like how a collection of simple musical notes can come together to create a melody, something that feels different from the notes themselves. And in a similar way, the universe shows levels of organization where new behaviors appear as structures become more complex, and this can be seen in many places, from the way weather patterns form in the atmosphere to the way living systems function. And you might ask, does this mean that complexity is inevitable, that given enough time, simple systems will always become more complex? And the answer is not entirely clear, because complexity depends on many factors, including the conditions and the interactions involved. And not all systems become more complex. Some remain simple or even break down over time, and this reminds us that the emergence of complexity is not guaranteed, but depends on a balance of conditions. And as you sit with this idea, the universe begins to feel like a place where simple beginnings can lead to rich outcomes, where small interactions can build into larger systems, and where patterns can evolve into structures that are capable of change, growth, and even awareness. And you might gently reflect on how this connects to everything we have been exploring, from the laws of physics to the balance of forces, because all of these elements create the conditions that allow complexity to arise. And in that sense, the universe is not just a static collection of objects, but a dynamic process, one that unfolds over time, gradually building layers of structure and organization. And this realization can feel both calming and inspiring, because it shows that even from the simplest beginnings, something meaningful can emerge, something that grows, changes, and becomes more than the sum of its parts. And as this thought settles, it invites a sense of quiet wonder, a feeling that there is a deep connection between simplicity and complexity, between the basic rules that govern the universe and the rich structures that arise from them. And that by continuing to explore and observe, we can slowly begin to understand how this transformation takes place, how the universe moves from simplicity to complexity, and how that process has led to the world we experience today, including our own ability to think, to question, and to reflect on the very nature of existence itself. As we gently follow this path from simple beginnings to growing complexity, we arrive at one of the most quietly astonishing moments in the story of the universe. the point where non-living matter began to form something that could grow, respond, and eventually become alive. And you might pause and wonder, how does that even happen? How do simple molecules, which are not alive, come together in a way that creates something living? Something that can take in energy, adapt, and reproduce. And to begin to picture this, imagine a collection of tiny building blocks, like scattered pieces on a table, each one simple on its own, but capable of connecting in different ways. And over time, under the right conditions, some of these pieces begin to form patterns that can hold together, patterns that can interact with their surroundings, almost like a small system that starts to maintain itself. And this is one way scientists think about the early stages of life, not as a sudden jump from non-living to living, but as a gradual process where chemistry becomes more organized, more dynamic, and more capable of sustaining itself. And you might ask, where did this happen? And one idea is that it may have taken place in environments like shallow pools or deep ocean regions where energy and chemical materials were available, allowing complex reactions to occur over long periods of time. And to help picture this, imagine a place where different ingredients are constantly mixing, like a slow, natural laboratory, where simple combinations can lead to more complex ones. And occasionally, a structure forms that is stable enough to persist and interact with its environment. And this leads to a gentle question: what makes something alive? What is the difference between a complex chemical system and a living organism? And while there is no single simple answer, one key idea is that living systems are able to maintain themselves, to process energy, and to reproduce in some form, creating copies or variations of themselves. And this ability to reproduce is important because it allows for gradual change over time, where small differences can lead to new forms and new behaviors. And you might wonder, how likely is it for life to arise from non-living matter? Is it something that happens easily under the right conditions, or is it a rare event? And this is still an open question, because while we understand some of the steps that could be involved, we have not yet observed the full process happening from start to finish. And many people assume that life appearing from non-living matter must be impossible. But that is not necessarily the case, because we know that the building blocks of life, like certain molecules, can form naturally under the right conditions. And experiments have shown that simple chemical systems can become more complex over time, suggesting that the transition from non-living to living may be part of a larger process rather than a sudden event. And yet, even with this understanding, the origin of life remains one of the most fascinating mysteries, because it represents a moment where the universe became capable of sustaining systems that could grow and evolve and eventually become aware. And you might gently reflect on how remarkable this is, that from the same basic particles and forces that shape stars and galaxies, there can arise something as intricate as a living cell, something that contains information, processes energy, and interacts with its environment in a coordinated way. And to help picture the scale of this complexity, imagine a system so detailed that even a single cell contains countless interactions happening at once, like a busy city where everything is working together in a coordinated way, and all of this emerging from simple beginnings over long periods of time. And this leads to another quiet question: does the origin of life point to something deeper about the universe? Does it suggest that the conditions for life are built into the structure of reality, or is it simply the result of chance events coming together in the right way? And different perspectives offer different answers, some seeing life as a natural outcome of the laws and conditions of the universe, while others see it as something more rare and special. And as you sit with this, the boundary between the non-living and the living begins to feel less sharp, more like a gradual transition, a continuum where complexity increases until something new emerges, something capable of growth and change. And in that sense, the origin of life becomes part of the larger story of the universe. A story where simple beginnings lead to greater complexity, and where the same underlying rules give rise to both stars and living systems. And as this thought settles, it invites a sense of quiet wonder, a feeling that life is not separate from the universe, but deeply connected to it, a natural extension of the processes that have been unfolding since the very beginning, and that by continuing to explore this mystery, we can slowly begin to understand how the universe gave rise to something that can observe it, reflect on it, and ask these very questions in the first place. As we quietly reflect on how life emerged from simple beginnings, another layer of wonder gently comes into view, something that feels even more subtle and difficult to define, and that is consciousness, the simple yet profound experience of being aware, of noticing thoughts, sensations, and the world around you. And you might pause and ask, what exactly is consciousness? Because unlike physical objects, you cannot hold it or point to it directly. It is something you experience from within, like the feeling of being present, of knowing that you are here, listening, thinking, wondering. And this leads to a quiet question: how does something like consciousness arise from physical matter? How do collections of atoms and molecules, following the laws of physics, give rise to awareness? And to begin to picture this, imagine a system becoming more and more complex over time, like layers building upon layers, where simple interactions lead to networks, and those networks begin to process information, respond to changes, and eventually create patterns that reflect the world around them. And at some point along this path, something new appears, not just behavior, but experience, a kind of inner perspective. And you might wonder, where exactly does that shift happen? Where does the transition from non-conscious to conscious occur? And the honest answer is that we do not fully know, because consciousness is not something we can measure in the same way we measure physical properties. We can observe behavior, we can study brain activity, but the actual experience, what it feels like to be aware, remains something that is directly known only from within. And this makes it one of the most fascinating mysteries, because it connects the physical world to subjective experience. And many people assume that consciousness is something separate from the universe, something that exists outside of physical processes. But another perspective suggests that consciousness may be an emergent property, something that arises when systems reach a certain level of complexity, like a pattern that appears when enough pieces come together in the right way. And to help picture this, imagine a network of connections, like a web, where signals move and interact, and as the network becomes more intricate, it begins to process information in more advanced ways, eventually leading to the ability to represent the world and respond to it. And in this view, consciousness is not a separate substance, but a process, something that emerges from the interaction of many parts. And you might ask, does this mean that consciousness is common in the universe? Or is it something rare? And this is still an open question, because while we know that consciousness exists in humans, and likely in many other living beings, we do not yet know how widespread it might be beyond our own planet. And as you sit with this idea, it can feel both grounding and expansive, because it suggests that the same universe that formed stars and galaxies also gave rise to systems that can experience and reflect on that universe. And you might gently consider what that means, that the universe is not only something that exists, but something that can become aware of itself through the beings within it, almost like a vast system that has developed the ability to observe its own structure. And this leads to another quiet question: is consciousness simply a byproduct of physical processes, or does it point to something deeper about the nature of reality? And different perspectives offer different answers, some seeing it as a natural outcome of complexity, while others see it as something more fundamental, something that might be woven into the fabric of existence in a way we do not yet fully understand. And as you reflect on this, the experience of being aware begins to feel less ordinary and more remarkable, because it connects you directly to the larger story of the universe, a story that began with simple particles and has unfolded into systems capable of thought and reflection. And to help picture this, imagine the entire history of the universe as a long unfolding process. And somewhere along that process, awareness appears, like a light turning on in a vast space, allowing the universe to be noticed from within. And in that sense, consciousness becomes part of the ongoing journey, not separate from it, but deeply connected to it. And even if we do not yet fully understand how it arises or what it ultimately is, the fact that it exists in some quiet wonder, a feeling that there is still much to explore, not only about the universe around us, but also about the experience of being within it. And as this thought settles, it gently reminds us that the ability to ask these questions, to reflect, to wonder, is itself part of the mystery, part of what makes the universe not just a collection of objects, but a place where awareness can emerge and where the question of existence can be asked from within existence itself. As we quietly reflect on the presence of consciousness, another idea begins to take shape, one that feels simple at first, but becomes more thoughtful the longer we sit with it, and that is the idea that the universe we observe is connected to the fact that we are here to observe it, and this is often called the anthropic principle. And you might wonder, what does that really mean? And in its simplest form, it suggests that the universe must be compatible with our existence, because if it were not, we would not be here to notice it. And that might sound almost obvious, like saying you can only see the view from a place where you are standing. But when applied to the universe, it takes on a deeper meaning, because it connects our existence to the conditions of the cosmos itself. And you might pause and ask, does this explain anything? Or is it just stating something that is already true? And the answer depends on how we think about it. Because in one sense, it reminds us that our perspective is limited, that we are observing the universe from a place where life is possible, and that might not be the case everywhere. And to help picture this, imagine walking through a vast landscape with many different environments. Some areas are too hot, some too cold, some too unstable, and only a few places are suitable for living. And if you find yourself in one of those places, it might seem natural to you, because it is where you are, but that does not mean all places are like that. And in a similar way, the anthropic principle suggests that we should not be surprised to find ourselves in a universe that allows for life, because if it did not, we would not be here to ask the question. And this leads to a gentle question. Does this idea explain why the universe is the way it is, or does it simply describe our situation within it? And this is where different perspectives come in. Some see the anthropic principle as a way of understanding why certain conditions appear fine-tuned, suggesting that among many possible universes, we are in one, where the conditions allow for observers, while others see it as a reminder of our observational limits. Not a full explanation, but a way to frame our understanding. And you might wonder, does this mean there could be many universes with different conditions, and we happen to be in one that works for life? And that idea connects to the concept of a multiverse, where different regions or universes could have different properties, and only some of them would support complexity and awareness. And to picture this, imagine a large number of possible settings, like different combinations on a control panel, where most combinations lead to simple or unstable outcomes, and only a few led to a rich and structured environment. And we find ourselves in one of those few, because it is the only kind where observers can exist. And this perspective does not necessarily explain why those possibilities exist in the first place, but it offers a way of thinking about why we observe the particular conditions we do. And as you sit with this idea, it can feel both grounding and a little humbling, because it reminds us that our view of the universe is shaped by the fact that we are here, that our existence is tied to the conditions we observe. And you might gently ask, does this reduce the mystery, or does it deepen it? And for many, it deepens it, because it shifts the question from why the universe is suitable for life to why there are conditions at all that allow for such suitability, and whether that is a result of chance, necessity, or something else. And this brings us back to the larger theme we have been exploring, the connection between the structure of the universe and the presence of observers within it. And you might notice that this idea does not provide a final answer, but rather a way of looking at the question from a different angle, a way of understanding that our existence is part of the story, not separate from it. And in that sense, the anthropic principle becomes less about explaining everything and more about framing our perspective, reminding us that we are observing the universe from within a set of conditions that allow us to exist, and that this perspective shapes what we see and how we interpret it. And as this thought gently settles, it invites a sense of quiet awareness, a feeling that our place in the universe is both natural and remarkable because it connects us to the larger structure of reality, while also highlighting the conditions that make our presence possible. And in that balance between observation and existence, between the universe and the observer, we find another layer of the mystery, one that encourages us to keep exploring, to keep questioning, and to remain open to the different ways of understanding how we fit into the vast and intricate system that surrounds us. As we gently sit with the idea that our universe allows for our existence, another possibility begins to quietly unfold, one that expands the picture even further, and that is the idea that our universe might not be the only one, that there could be many universes, each with different properties, different conditions, and perhaps even different laws. And you might pause and ask, what does it mean to have multiple universes? Are they like separate spaces floating somewhere far away, or something more subtle? And the truth is, we do not yet know for certain, but the idea comes from attempts to understand why our universe has the special characteristics it does, especially when those characteristics seem finely balanced. And one way to think about this is to imagine not just one set of conditions, but many possible sets, like trying different combinations on a control panel, where each combination leads to a different kind of universe, some simple, some complex, some stable, some not. And among all these possibilities, there may be a range of universes, each with its own structure, and we find ourselves in one where the conditions allow for complexity and life. And you might wonder, how could such multiple universes come into existence? And one idea is that during the early stages of cosmic expansion, space itself may have expanded in a way that created separate regions, each evolving independently, like bubbles forming in a large, expanding field, where each bubble becomes its own universe, with its own properties. And to help picture this, imagine boiling water, where bubbles appear and grow, each one separate, but part of the same process. And in a similar way, the multiverse idea suggests that our universe could be one of many such regions. And this leads to a gentle question. Can we observe these other universes? Can we detect them in any way? And at the moment, there is no direct evidence that allows us to see or interact with other universes, because if they exist, they may be separated from us in ways that prevent any form of communication or observation, like being in one bubble without access to the others. And this is where some people feel uncertain about the idea, because it is difficult to test directly, and science usually relies on observation and evidence. And yet, the multiverse theory is explored because it offers a way to explain certain features of our universe, especially the apparent fine-tuning we discussed earlier. And you might ask, does this mean that everything that could happen does happen somewhere? And while that is one way to think about it, the exact nature of a multiverse if it exists, is still uncertain, and different models suggest different possibilities, some more limited, some more expansive, and as you sit with this idea, it can feel both vast and abstract, because it stretches beyond our usual way of thinking about space and reality. And you might gently reflect on what this means for the question we began with: why this universe? Why these conditions? And the multiverse perspective suggests that our universe might be one outcome of many, and that we observe it because it is one where observers can exist. And this connects back to the anthropic principle, where our presence is linked to the conditions we observe. And yet, even with this idea, the deeper question remains: why is there a multiverse at all? Why should there be many universes instead? And this shows that while the multiverse theory can shift the question, it does not remove the mystery. It simply moves it to a different level. And as you sit with this, you might notice that the idea of multiple universes does not necessarily make our own universe feel less meaningful, but in some ways, more so, because it highlights the specific conditions that allow for the structures we see, and for the existence of beings who can reflect on those structures. And to help picture this, imagine a vast landscape with countless possibilities, and among them, certain paths lead to environments where life can arise, and we find ourselves on one of those paths, and in that sense, the multiverse idea becomes part of the broader exploration, not a final answer, but a way of thinking about the range of possibilities and how our universe fits within that range. And as this thought gently settles, it invites a sense of openness, a feeling that reality may be larger than we currently perceive, that there may be layers and possibilities beyond what we can directly observe, and that by continuing to explore these ideas, we can expand our understanding, even if we do not yet have all the answers. And in that ongoing journey, the concept of a multiverse becomes another piece of the puzzle, another way of looking at the question of existence, and another invitation to remain curious about the vast and intricate nature of reality, and how our universe, with all its structure and complexity, fits into a picture that may be far larger than we can currently imagine. As we continue to gently explore the idea of multiple universes, the mind naturally drifts toward an even larger possibility, one that feels almost impossible to fully grasp, and that is the idea of not just many universes, but perhaps an infinite number of them. And you might pause and ask, what does infinite really mean in this context? Because infinity is not just a very large number, it is something without end, something that continues without limit, like counting numbers that go on forever, where no matter how far you go, there is always another step ahead. And now imagine applying that idea to universes, to entire realities, each with its own structure, its own conditions, and possibly its own versions of events. And this leads to a quiet sense of vastness that can be difficult to picture, like trying to imagine a horizon that keeps expanding the more you approach it, never reaching an edge. And you might wonder, is this idea of infinite universes something supported by science? Or is it more of a philosophical thought? And the answer is that it lies somewhere in between, because certain theories in physics suggest the possibility of an unbounded or continuously generating set of universes, especially in models where space keeps expanding and creating new regions. And if that process never stops, then the number of universes could grow without limit. And to help picture this, imagine a process like a tree that keeps branching, where each branch splits into more branches, and each of those splits again, continuing endlessly. And if that branching never ends, then the number of branches becomes effectively infinite. And in a similar way, the multiverse idea can extend into an infinite landscape of possibilities. And this leads to a gentle question. If there are infinite universes, does that mean every possible version of events exists somewhere? And while this is one interpretation, it depends on how we define what is possible. and how these universes differ. And some ideas suggest that different universes may have different laws or constants, while others suggest variations of conditions within similar frameworks. And as you sit with this, the concept of infinity begins to stretch the imagination, because it goes beyond what we can easily visualize. And yet, it also raises interesting questions about probability and uniqueness, because if there are infinitely many universes, then even rare conditions might occur somewhere. And you might gently ask, does that make our universe less special, or does it simply place it within a larger context? And this is a question that does not have a single answer, because it depends on how we interpret the idea. For some, the possibility of infinite universes makes our own existence feel like one outcome among many, while for others, it highlights the remarkable nature of the conditions that allow for awareness and reflection, regardless of how many other possibilities exist. And you might also wonder, can we ever confirm the existence of infinite universes? Or is this something that will remain beyond our direct observation? And at the moment, it appears that such ideas may be difficult to test in a direct way, because they extend beyond the limits of what we can observe. And this brings us back to the idea of the limits of our understanding, how there are questions that push beyond what we can measure or see, and yet still invite exploration and thought. And as you reflect on this, the idea of infinite universes becomes less about counting or measuring and more about expanding perspective, about recognizing that the universe we experience may be part of something far larger, something that may not have clear boundaries or limits. And to help picture this, imagine standing at the edge of a vast ocean where the horizon stretches endlessly. And even though you cannot see beyond it, you sense that there is more, that the water continues far beyond your view. And in a similar way, the concept of infinite universes suggests a reality that extends beyond what we can currently observe, and this can feel both humbling and calming, because it reminds us that our understanding is always growing, always expanding, and that there may always be more to discover, more to consider, and more to wonder about. And as this thought gently settles, it invites a sense of openness, a willingness to explore ideas that go beyond our immediate experience, and to appreciate the depth and vastness of the questions we are asking. And in that quiet space, the idea of infinite universes becomes not just a concept, but part of the larger journey of curiosity, a way of thinking about existence that stretches the imagination and encourages us to keep exploring, even when the answers are not fully within reach, and to remain comfortable with the mystery that comes with considering a reality that may have no end at all. As we gently sit with the idea of countless universes, perhaps even an infinite number, another possibility begins to quietly emerge, one that feels both familiar and unusual at the same time. And that is the idea that reality itself might be constructed in some way, something often called the simulation hypothesis. And you might pause and ask, what does that really mean? Does it suggest that everything we experience is like a kind of program or system, similar to the digital worlds we create on screens? And while that comparison can help us picture it, the idea is deeper than just imagining a computer game, because it raises the question of whether the reality we experience is the most fundamental level, or if it is built upon something else, something underlying that we do not directly perceive. And to begin to picture this, imagine being inside a very detailed virtual world, one that feels real in every way, where you can see, hear, and interact with your surroundings. And from within that world, everything appears consistent and governed by rules, but those rules are part of a system that exists beyond the experience itself. And in a similar way, the simulation hypothesis suggests that our universe might operate according to rules that are part of a deeper framework. And you might wonder, is there any reason to consider this idea seriously? Or is it just a thought experiment? And while it may sound like something from imagination, It has been discussed in philosophy and science as a way of exploring the nature of reality, especially as our own ability to create complex simulations continues to grow. And you might gently ask, if we can create simple simulated environments, could more advanced systems create realities that are indistinguishable from what we experience? And if so, how would we know whether we are in one? And this is where the idea becomes more subtle. Because if a simulation is detailed enough, it might be impossible to tell from within it whether it is simulated or fundamental, like being inside a story that feels completely real from the inside. And this leads to another quiet question. Does the simulation hypothesis explain anything about the universe, or does it simply shift the question to another level? And in many ways, it does the latter, because even if our universe were part of a simulation, we could still ask, what created the system that runs the simulation? What are the rules at that deeper level, and why does it exist at all? And so the mystery is not removed, but extended, like opening one door only to find another beyond it. And you might also wonder, are there any clues that could suggest we are in a simulation? And some ideas have been proposed, such as looking for limits in how reality behaves, like patterns that might hint at an underlying structure. But so far, there is no clear evidence that confirms or rules out this possibility. And as you sit with this idea, it can feel both intriguing and a little abstract, because it challenges our usual assumptions about what is real. And yet, it also connects to the deeper questions we have been exploring about the nature of laws, patterns, and the structure of existence. And you might gently reflect on how this idea relates to the effectiveness of mathematics, because if reality follows precise rules, it can feel similar to a system that operates according to defined instructions. And yet, even if that comparison holds in some ways, it does not necessarily mean that reality is literally a simulation. But it does invite us to consider that what we experience may not be the final layer of reality. And this leads to a calm and open question. What is the most fundamental level of existence? And is it something we can ever fully access or understand? And as you sit with this, the simulation hypothesis becomes less about proving or disproving a specific idea, and more about expanding perspective, about considering different ways of thinking about reality, and recognizing that our current understanding may be part of a larger framework. And to help picture this, imagine reading a story where the characters are unaware of the world beyond the pages, and from their perspective, everything they experience is real and complete. And yet, there is another level that contains and supports their world. And in a similar way, the simulation idea invites us to consider whether our universe might be part of a larger structure, one that we are only beginning to imagine. And as this thought gently settles, it does not demand a conclusion, but instead invites curiosity, a willingness to explore possibilities, and to remain open to the idea that reality may have layers beyond what we currently perceive. And in that quiet openness, the question of whether we are in a simulation becomes part of the larger journey, not a final answer, but another way of asking what reality truly is and how deeply it extends beyond the surface of our experience. As we gently explore these possibilities, from multiple universes to the idea that reality itself might have deeper layers, another quiet realization begins to settle in, and that is the idea that there may be limits to what we can know, limits not just in what we have discovered so far, but in what we may ever be able to fully understand. And you might pause and ask, what does it mean for science to have limits? Because science has achieved so much. It has explained the motion of planets, the behavior of matter, the origins of stars, and so many other things that once seemed mysterious. And it might feel natural to think that, given enough time, science will eventually answer every question. But when we look more closely, we begin to see that some questions reach beyond what science is designed to address. And you might wonder, why is that the case? What kind of questions are beyond its reach? And to begin to picture this, imagine science as a tool, a very powerful tool that helps us observe, measure, and test the world around us, like a flashlight that allows us to see in the dark. And with this flashlight, we can explore many things. We can examine objects, understand patterns, and make predictions. But the flashlight has its limits. It can only illuminate what is within its range, and there may be areas beyond that range that remain in shadow, not because they are unreachable forever, but because they may require a different kind of approach. And one example of this is the question of why there is something rather than nothing, which we began with, because while science can describe how the universe behaves and how it has evolved, it may not be able to fully explain why existence itself is there in the first place. And you might gently ask, is that a failure of science, or simply a reflection of its purpose? And it is more likely the latter, because science is designed to study patterns and relationships within the universe, not necessarily to answer questions about why the universe exists at all. And another example comes from the idea of what happened before the beginning of the universe. Because if time itself began with that moment, then asking what came before may not have a clear meaning within the framework of science, like asking what is north of the North Pole, where the concept itself does not apply. And this does not mean the question is unimportant, but it shows that some questions may require different ways of thinking. And you might also consider the limits of observation, because there are parts of the universe that we cannot see, regions so far away that their light has not had time to reach us. And to picture this, imagine looking out across a vast ocean where you can only see as far as the horizon, knowing that there is more beyond it, but unable to observe it directly. And in a similar way, there are limits to how much of the universe we can access through observation. And beyond that, there may be aspects of reality that are fundamentally beyond measurement, not because we lack the tools, but because they do not interact with us in a way that allows for measurement. And this leads to a gentle question: does this mean we should stop asking these deeper questions? And the answer is no, because curiosity is not limited by what we can measure. It extends beyond it, inviting us to explore ideas, to reflect, and to consider different perspectives. And while science provides one powerful way of understanding the universe, it is not the only way we engage with these questions. And as you sit with this, you might notice that the limits of science do not make the universe feel smaller, but in some ways larger, because they remind us that there is still mystery, still unknown space for thought and reflection. And this can feel both humbling and calming, because it shows that we are part of an ongoing process of discovery, one that does not have a final endpoint, where everything is fully explained, but instead continues to unfold, revealing new layers and new questions over time. And you might gently reflect on how this connects to everything we have been exploring, from the origin of the universe to the nature of consciousness, because each of these topics touches on areas where our understanding is still growing and where some aspects may remain open questions. And in that sense, the limits of science are not barriers, but boundaries that help define the space of exploration, like the edges of a map that show where we have reached so far and where there is still more to discover. And as this thought settles, it invites a sense of quiet acceptance, a willingness to embrace both what we know and what we do not know, and to continue asking questions with curiosity, and openness, recognizing that the journey of understanding is ongoing, and that even the limits themselves can be part of what makes that journey meaningful and deeply engaging, as we gently recognize that there may be limits to what science alone can answer. Another quiet layer of understanding begins to open, one that brings together different ways of looking at the universe, And that is how people interpret the idea of creation, not just in a scientific sense, but also through philosophical and personal perspectives. And you might pause and ask, what does creation really mean? Does it refer to a specific moment when everything began, or does it point to something deeper about why the universe exists at all? And the answer can vary, depending on how we approach the question, because different perspectives offer different ways of understanding the same mystery. And one way is the scientific perspective, which focuses on how the universe began and evolved, describing processes like expansion, the formation of stars, and the development of structure over time. And this perspective is grounded in observation and evidence, helping us understand the sequence of events that led to the universe we see today. And you might wonder, does this explain creation completely? And while it explains many aspects of how things happened, it does not fully address why there is something rather than nothing, or why the laws of physics exist in the way they do. And this is where philosophical perspectives begin to come in, exploring questions about existence, cause, and meaning, asking whether the universe requires an explanation beyond itself, or whether it can be understood as something that simply exists as a fundamental reality. And you might gently consider how these questions have been explored for a long time, with thinkers reflecting on the nature of existence, asking whether there must be a first cause, something that sets everything into motion, or whether the chain of causes can extend indefinitely without a clear beginning. And these ideas do not always lead to a single conclusion, but they open a space for reflection, a space where different possibilities can be considered. And alongside these perspectives, there are also personal and reflective ways of thinking about creation, ways that connect the idea of existence to meaning and purpose, where the universe is seen not just as a system of matter and energy, but as something that invites wonder, curiosity, and a sense of connection. And you might ask, do these different interpretations contradict each other? Or can they exist together? And in many ways they can complement each other, because they address different aspects of the same question: science, exploring how the universe works, philosophy exploring why it exists, and personal reflection exploring what it means for us. And to help picture this, imagine looking at a landscape from different viewpoints. One person might focus on the physical details, the shapes and patterns of the terrain. Another might reflect on the deeper meaning of the scene, and another might simply experience it with a sense of wonder. And all of these perspectives offer something valuable, even though they approach the same landscape in different ways. And in a similar way, the idea of creation can be explored through multiple lenses, each adding to our understanding without necessarily cancelling the others. And as you sit with this, you might notice that the question of creation becomes less about finding a single final answer and more about exploring the richness of the question itself, about recognizing that the universe can be understood in different ways, depending on how we look at it. And this does not mean that all interpretations are the same, but that they each contribute to a broader picture, a picture that includes both explanation and reflection, both observation and meaning. And you might gently reflect on how this connects to your own sense of curiosity, how the question of where everything comes from is not just a distant idea, but something that touches on your own experience of being here, of observing, of wondering. And in that sense, the idea of creation becomes something personal as well as universal, something that connects the vast scale of the cosmos to the quiet awareness within. And as this thought settles, it invites a sense of openness, a willingness to consider different perspectives without rushing to choose one over the others, and to appreciate the depth and complexity of the question itself. And in that quiet space, the idea of creation remains not as a problem to be solved once and for all, but as an ongoing exploration, one that continues to unfold as we learn more, think more deeply, and reflect on the nature of existence from different angles, gently bringing together science, philosophy, and personal experience into a single continuous journey of understanding. As we gently come to rest after exploring all these layers, from the beginning of the universe to the possibility of many realities, from the laws that shape everything to the quiet emergence of life and awareness, a final realization begins to settle in, not as a sudden answer, but as a calm understanding that grows slowly. And that realization is this: that no matter which path we follow, whether we think in terms of chance, necessity, or design, the simple fact remains that the universe exists and we are here within it, able to notice it, to question it, and to reflect on it. And you might pause and ask, is that enough? Is simply recognizing existence itself a kind of answer, or does it leave something unfinished? And the truth is, it can be both. Because on one hand, we may not have a complete explanation for why everything exists in the way it does, but on the other hand, the fact that it exists at all is something deeply remarkable, something that does not need to be rushed into a final conclusion. And you might gently reflect on how every idea we have explored, from the fine balance of forces to the possibility of infinite universes, has pointed toward the same quiet mystery, that reality is structured in a way that allows for complexity, for growth, and for awareness. And to help picture this, imagine standing in a vast landscape that stretches far beyond what you can see, where every direction holds more depth, more detail, and more possibilities. And even though you cannot explore it all at once, the simple act of standing there, of being present within it, becomes meaningful in itself. And in a similar way, the universe can be seen not just as a problem to solve, but as something to experience, to observe, and to reflect on. And you might ask, does this mean we should stop searching for answers? And the answer is no, because curiosity is part of what connects us to the universe. It is part of how we engage with the mystery. But at the same time, there is a quiet balance between searching and accepting, between asking questions and simply noticing what is already here. And as you sit with this, you might notice that the question we started with, why there is something rather than nothing, does not feel as heavy as it once did, not because it has been fully answered, but because it has been explored from many angles, each one adding depth and perspective. And in that process, the question itself becomes part of the experience, something that invites ongoing reflection rather than demanding a final resolution. And you might gently consider how this connects to your own awareness, the simple fact that you are here, listening, thinking, and being part of this moment, and that awareness itself is part of the larger story, a story that began long before and continues to unfold. And to help picture this, imagine the entire history of the universe as a long, flowing path stretching across time. And somewhere along that path, awareness appears, allowing the universe to be noticed from within. And in that sense, you are not separate from the universe, but a part of it, a point where it becomes aware of itself. And this realization can feel both grounding and expansive, because it connects the smallest moments of experience to the larger scale of existence. And you might ask, does this point to a deeper meaning? Or is it simply the way things are? And different perspectives may answer that in different ways. But regardless of the interpretation, the presence of awareness, the ability to question and reflect, remains something quietly profound. And as this thought settles, it brings a sense of calm, a feeling that not everything needs to be resolved in order to be meaningful, that the mystery itself can be something to appreciate, something that adds depth to our understanding and experience. And you might notice that even without a final answer, there is a sense of connection, a feeling that the universe and your awareness of it are part of the same unfolding process, and in that quiet realization, the journey comes full circle, not by closing the question, but by opening it into something wider, something that invites continued curiosity, continued reflection, and a gentle appreciation of the fact that anything exists at all, including this moment, including this awareness, and including the simple, quiet act of wondering about it.